Assalamualaikum. My name is Muhammad Azif Fahmi bin Abdul Ghani, and my matrix number is 01DKM20F2021. So for the introduction, a thermal power plant is a sizable electricity generating facility that use a complicated and interconnected system to convert heat energy into electrical energy. It is essential for supplying the rising energy needs for societies all over the world. Thermal power plants offer a dependable and continuous source of electricity for residential, commercial, and industrial use by utilizing the thermal energy created during the burning fossil fuels or nuclear processes. A thermal power plant's main goal is to effectively transform thermal energy into electrical energy. Each stage in the procedure, which is made up of several related ones, contribute to the overall production power, combustion of fuel, heat transport, energy conversion, and power transmission are some of these phases. The conversion of thermal energy into electrical energy takes place in thermal power plants, which are crucial facility for the production of electricity. These power plants use nuclear or fuel combustion process to produce energy which is consistent and dependable supply that helps society advance and expand. While helping to meet the world's demand for electricity, thermal power plant also present environmental risks. Fossil fuel combustion emit greenhouse gases and other pollution, which contribute to both air pollution and climate change. Next is thermal discharge. Thermal discharge are the release of heated water or chemicals into the environment as a result of numerous industrial activities, such as those in thermal power plants, manufacturing facilities, and other operations that produce heat as a byproduct. If this discharge affect water bodies like rivers, lakes, or seas, they may have an effect on the environment. Thermal discharge may disturb the receiving water body's natural equilibrium. The implication of rising water temperatures include decreased oxygen level, altered aquatic ecosystems, altered species composition, and increased susceptibility to diseases. Aquatic animals, especially those that are prone to temperature variations, could experience stress, produce fewer young, or perhaps die extinct. That's all from me. Thank you.
Okay. Now we go for the factors. Several factors influence thermal discharge from a thermal power plant. These factors determine the magnitude and impact of the thermal discharges on the receiving water body. Here are some key factors that contribute to thermal discharge. The first one is water source and availability. The source and availability of water for cooling purpose influence thermal discharges. Power plants located near large water bodies or rivers often have access to abundant cooling water, which can aid in heat dissipation. Conversely, power plant in arid regions of those related on limited water source may face challenges in managing thermal discharges due to the water scarcity. The second factor is to be discharges point and flow rate. The location and flow rate of discharged water can impact the dissipation and dilution of heat in receiving water body. The proximity of the discharges point to sensitively ecosystems or area with high ecological value determined to potential environmental effect. Adjusting the flow rate of discharged water can be dissipate heat and minimize the location, determine the impact.
So we are going on to the next, which is effects. Significant amounts of cooling water are used in thermal power plants with steam generators and swans through cooling system for condensing steam turbine exhaust and cooling auxiliary equipment. Because many aquatic creatures are biologically sensitive to the changes in water temperature, temperature rises brought on by power plant discharge may have a variety effect on the aquatic ecosystem. Direct impacts and indirect effects are two main categories of thermal discharges. Effects on the aquatic environment. The direct effects of thermal discharges on the water environment include a change in the temperature regime of water column and in some cases the sediment, lethal and sublethal response of water body organisms to the change in temperature regime. Inhibited biological process stress, administrations of productivity, a variety of organisms leading to increased respiration rates. Changes in distribution compositions and growth rates of communities of water body creatures, including fish and macrovertebrates. Implications of on the distributions of bird populations depend on these are only few of the indirect consequences of thermal discharge on the aquatic environment, altered nutrition and carbon cycling in the organisms.
My name is Mamindran, son of Shashindran, and my matrix number is 01DKM20F2016. Now I'm going to elaborate about the solutions. First of all, regulations and procedures. Generally speaking, thermal discharge should be planned to prevent discharge water temperature from exceeding pertinent ambient water temperature limits outside of a mixing zone that has been scientifically verified. The mixing zone is typically defined as the area where the initial dilution of a discharge occurs and where relevant water quality temperature standards are permitted to be exceeded. This area also takes into account factors such as potential receptors, assimilative capacity, the cumulative impact of seasonal variations, ambient water quality, receiving water use, and other factors. To prevent or minimize the potential impacts of thermal discharges from a thermal power plant on the receiving water body, several preventive measures can be implemented. These measures aim to reduce the temperature of the discharge water and mitigate any adverse effect of the aquatic ecosystem. Secondly, efficient cooling systems. Implementing efficient cooling systems is crucial to reduce the temperature of the discharge water. Cooling towers are commonly used which transfer heat from the water to the atmosphere through evaporation. Cooling ponds or lagoons can also be utilized, allowing for natural cooling through heat dissipation. Advanced cooling technologies such as closed-loop cooling systems or hybrid cooling methods can further enhance the cooling efficiency. Thirdly, thermal mixing zones. Establishing thermal mixing zones can help to dissipate the heat from the discharge water and minimize the thermal impact on the receiving water body. These zones allow for the blending of discharge water with the ambient water, facilitating natural cooling and reducing the temperature gradient. The size and the location of the thermal mixing zone should be determined based on the specific characteristics of the water body and the anticipated thermal effects. Last but not least, the flow management. Proper management of the flow rate and the velocity of the discharge water can contribute to temperature reduction. Adjusting the flow rate can help disperse the thermal plume, allowing for better heat dissipation. Controlling the velocity can prevent the accumulation of heated water in specific areas, minimizing the localized thermal impact. Lastly, environmental monitoring. Implementing a comprehensive environmental monitoring program is essential to assess the effectiveness of preventive measures and ensure compliance with regulatory requirements. Regular monitoring of water temperature, water quality parameters, and the ecological health of the receiving water body can help detect any potential impacts and guide the adjustment of mitigation strategies if necessary.
My name is Wan Muhammad Akil bin Wan Mastok Sharif, and my metric number is 01DKM20F2017. So the conclusion for this case study is thermal discharge, which is connected to a variety of industrial operations such as thermal power plants and manufacturing facilities, is a significant environmental concern. Aquatic ecosystem, water quality, and the creatures that depend on this ecosystem for survival may be negatively impacted by the release of hot water and other pollutants into water bodies. To reduce the negative ecological effects and preserve the long-term sustainability of water supplies, effective thermal discharge management is crucial. For the purpose of regulating the temperature of discharge water and minimizing potential harm, best practice procedures and regulation have been devised. These precautions include establishing temperature restrictions, putting in place efficient cooling system, creating thermal mixing zones, and keeping an eye on water quality indicators. Collaboration between regulatory agency, business and environmental stakeholders is necessary for the proper management of thermal discharge. Industrial facilities can lower their environmental impact and the thermal impact to their emission by following rules, implementing sustainable practice and spending money on innovative technology. In the end, it's important to establish a balance between economic activity and protection of ecosystem and water supplies. We can conserve the health and integrity of water bodies, preserve biodiversity and guarantee a sustainable future for future generation by reducing the negative effect of thermal discharge and encouraging appropriate practice. That's all from me. Thank you.